So today we're going to talk about a critical challenge in our industry. So this presentation is built on the lessons we've learned at TensorOps, scaling LLM agents to thousands of users. If the slide will move to the right. Give me a second. Seems too far. Yeah. I've skipped over a slide now. Okay, cool. So thanks for your patience. We're seeing a huge investment in AI. And so MIT released this study in August this year. You've probably seen a study like this every couple of months, maybe for the last 2 or 3 years. Maybe the probability or the percentage kind of fluctuates around a little bit. I think you probably need to look at the MIT study in detail to see sort of their definition of failure. And you might disagree that 95% is too high. You might think it's too low. But I think what this kind of study and other studies like it are showing is that getting AI projects off the ground, landed into production, and delivering real value for users is a challenge. And I think it's something that we as practitioners need to think about and address. So, it's really about not just building that. Seems like there's a bit of latency transition. So yeah, so that's what we're going to talk about this evening. But first of all, a few introductions. So my name is Darren Bryan, and Alex already introduced me. I work for a company called TensorOps. We're an AI first consultancy. We've recently expanded into the UK, and I'm the country lead for TensorOps here. TensorOps was founded in 2022 by Gad Benram and Claudio Lemos. Claudio's somewhere in the audience. Say hi, Claudio. There he is. And so TensorOps is an AI first consultancy, so we help customers to get their AI applications into production for their customers. And what does our production look like? Yeah, so I'm just struggling with the transitions. So, it doesn't seem to be. Yeah. Okay. Okay, cool. Thanks for that. So this is what our production looks like. I need to move the mouse off there. Thank you very much. So Seeking Alpha is a financial news and analysis company. This is one of the most exciting projects I've ever worked on. We were really humbled to work with Seeking Alpha to help them build out their Ask SA copilot. So this is a live customer-facing production system. It's a production-grade system that allows users to perform complex financial research. So I think Seeking Alpha's kind of business, they've got a lot of internal proprietary data, news articles, and also analysis of companies. Searching that data set is a real challenge for users. And so an agentic approach, allowing users to sort of invert their search and ask natural language queries of the data and get interesting results back is a really valuable addition to their services. So as you can see here, it's a little bit blurry, but companies suspected to be acquired provide analysis, and the agent's able to respond back with a ranked ordered list of interesting companies that the user can then take a look into. This isn't providing financial advice. It's not providing like investment guidance. It's providing the customer with the information that they've asked so that they can make their own investment decisions. So we were really humbled to work with Seeking Alpha to build this out. And through this work, we were able to sort of work with and deliver an agentic system to hundreds of thousands of users. And this isn't just a demo, as I've sort of said. You can go onto the Seeking Alpha website, sign up for their premium membership, and start to use this product. So not gonna make the. Here we go. So this is the Portugal Post. So this is a news website that we helped to build. This is a 100% autonomous content generation and publishing pipeline, feeding all of the news stories every day on the Portugal Post. It's all running on GitHub Actions. And so we built an autonomous news organization with no people working at it. So it's like, in some ways, the holy grail of AI right now, the idea of having an entirely autonomous organization. You can go to the Portugal Post website right now today. You can look at the website and see what articles are up there. Hopefully it won't look like this, which was from around a week ago. And, you know, obviously an autonomous system may mean a different thing depending on the context of the company that you're working at. Obviously a static news website is quite different to a financial services company. You might not want to go fully autonomous with that, but I think having this this sort of North Star, sort of guiding light to sort of see what's possible, and you know that building an autonomous organization is an achievable goal, sort of challenges us all to think about how our application and our product might work in production. Should have tested these transitions before we did the AV. Sorry, folks. Is this right? So I've got my notes here. Okay. So, okay. So I think the people at the in this room, if you've been coming to these talks for a fair while, certainly the Selden folks in the room, they'll be pretty familiar with the left-hand side of this slide. So we're all familiar with MlOps context, some of the challenges of accelerating the delivery of models into production. So one of the CTOs at a fintech company that we work at, some of the models we develop take many months to get to production, and some of them have taken 7 months. So I think this is a well-understood problem. I think it's a problem that MlOps as a movement sort of started out 5-10 years ago to to address and make more straightforward. I think a more common, an increasingly common sort of alternative challenge that I see with the customers that I'm working with and talking to on a regular basis is that it's never been easier to build a really compelling demo. The threshold for building building a demo app that you can put in front of your senior leadership team to show them the art of the possible with especially with generative AI, give me access to copilot and an LLM, and we can build that in an afternoon. I think where I often see customers really struggling is getting past that demo to something that's combining their data, access to their systems of record, their APIs, and to actually do interesting things and valuable things for users while they're sort of working on that. So we call that demo purgatory. So a bit of a model for sort of the map of what we're going to sort of talk through this evening. So we're going to talk a little bit about the symptoms of some of the reasons why making that bridge from demo to production is hard. We're going to give you some sort of tools and some sort of thought patterns to apply to your projects, your organizations, to think about how to sort of do a technical health check for where you are. We're going to think about those symptoms and sort of map that onto a maturity model that helps us to understand, where we want to get to. Obviously, Rome wasn't built in a day, so we're not going to, go from zero to hero in one step. But I think having a sort of systematic approach to go from A to B, is a good way to move forward. We're going to build that maturity model on top of the core pillars, which we'll go through. We'll talk about some techie stuff. So we'll go through a bit of an architectural deep dive and talk about some lessons that I wish I'd had at the start of this year, some lessons that we've derived and learned at TensorOps building these applications. And there'll be plenty of time for questions and after the summary for the Q&A. Okay, so is any of this familiar to anybody? Any of these kind of symptoms, something that you've maybe encountered before? So I think obviously it's fine to work in notebooks, but something I'm seeing a lot and have seen for the last 5 or so years experiments and things stuck in notebooks make it very difficult to sort of move those solutions into production. Thin wrapper syndrome. So this is what I call when you've got an agentic system or an interaction with an LLM that's basically some very simple prompts in a notebook that you're maybe just calling into. There isn't anything particularly dynamic. You're maybe not bringing a lot of your own data to the system. So obviously that goes hand in hand with some of these integration struggles. How can we combine the LLM calls with the data that we want to use to derive insight and deliver value for customers? And obviously infrastructure overhead, data scientists spending more time on infrastructure than model engineering. So these are all symptoms that sort of signal a system cannot scale and puts your AI investment at risk. You might be familiar with this sort of diagram at the top. So this is a diagram from like a paper that I think Google wrote and put together a way back now, maybe in 2019, something like that. So it's called the hidden technical debt of ML systems. They were calling it ML back then. It's AI now. So I think the sort of nugget of insight that I took from that paper is you've got the black box in the middle of the page there. That's the ML code. This is kind of analogous to, I think, what Alex was talking about in his intro. But it's really all of the systems that sit around that ML code that introduce the complexity and sort of deriving and aligning the ML code, the thing that we spend a lot of time talking about in these kinds of meetup groups with all of your data, your features, your verification, and obviously your infrastructure and serving, is where a lot of the complexity comes from. And so, that's the challenge of going from demo to production. It's combining, your ML code with all those systems that sit around it. So a technical maturity model for GenAI. So if you're exhibiting a lot of those symptoms that we had on the last slide, then you're probably at level 0. So simple prompts, basic API calls, often in notebooks, pretty high risk of demo purgatory there. Level 1's the next step up, and it's the first level where we're combining our data with the queries and the input from users. And so this is the first chance for us to actually derive real value from the services that we're offering, combining AI into our products. So you might have built your first agentic tool, which is interacting with APIs, accessing data in your systems of record, and able to provide useful responses to users based on the queries that they've sent in. I guess the Portugal Post is a good example of like a level 2 autonomous system. So here we're talking about sophisticated, reliable agents that perform complex multi-step tasks with minimal human intervention. So that's the sort of spectrum that we're looking at. And to sort of make that transition and think about those levels, we've got our 3 Ps. So you need a reliable and scalable infrastructure. You need to think about your MlOps processes, your LLM ops processes, and think about the governance that you've got around how you're delivering projects into production. And of course, all the technology and all the process don't mean very much if you haven't got the right team. So that's also an essential part of of the setup. So let's start with the platform. You can't build a highway on a shaky foundation. So we need to think about 1 to 3 here. So integrating MLOps and LLM ops. So the way I like to sort of think about this is, obviously definitions, vary, but MLOps and the reason it came about was sort of inspired by the DevOps movement. The sort of key insight for me was that it was talking about there's an extra dimension of change in ML systems, and that's to do with the data. And so we need to kind of encapsulate and sort of legislate for that extra degree, extra dimensionality. And when we're talking about LLM ops, I think one of the major things which we'll come on to that makes it different from MLOps is managing prompts and thinking about how you dynamically can control across all the models that you're working with those prompts. That's one of the real challenges. Of course, you're going to need, there are lots of frameworks that do this, but obviously LangChain's one of them. You're going to need to sort of have an abstract, sort of an agent that's able to abstract the complexity. You want to use a framework for the connection to LLMs and to your tools and to get access to interesting data and APIs. And I think often a less talked about component that we leverage an awful lot at TensorOps is this sort of concept of an intelligent router. So this really enables us to have intelligent, valuable responses to users that can understand the intents of the queries that are coming in from our users and send them to the appropriate sort of path through the graph in our agentic system. So a little more on that intelligent query router. So this is your traffic controller directing queries to the right tool or model, and it really sort of pretty essential for the performance and cost management. A simple query that comes into our system that we can answer easily, maybe do some simple data lookups. We shouldn't be sending that to a large model that's going to, first of all, cost more for us to send on the tokens, and also is going to take a longer time to respond. If we want to respond in a timely fashion for our users, we need to sort of design the system to use the appropriate tool for the job. And so the intelligent query router's kind of job is to manage that. Model agnosticism is an interesting one. I've definitely worked with companies who maybe didn't think about this or thought that this wasn't a valuable or interesting thing for them to consider sort of day one for their projects. I think when you spend some time thinking about it, I think it's an essential thing for you to consider. And I think building model agnosticism from day one is really, really important. If you'd built your model on OpenAI's O3 family, maybe 6-8 months ago, your production application now wouldn't have a home because O3 is no longer available. You'd be using ChatGPT-4, ChatGPT-5. And so thinking about how you're going to model access to different LLMs and have some agnosticism there is really important. That doesn't necessarily mean you need to be thinking about going to different providers, maybe just talking about models in the same family and being able to manage model versions. But I think it's a really important consideration to think about if our application is successful, and hopefully all of you are going to go away now and build successful AI projects. Then you need to consider that for the lifetime of the product that you're building, how are you going to migrate and move that model over time? We talked a little bit about prompts when we were talking about LLM ops. So it's really important to store prompts in version control repositories and use your templating engines so that you can insert the user's query into your prompts efficiently. And they're really required so that you can implement that A/B testing to systematically improve performance. I haven't forgotten the logging on the and tracing on the previous slide. I thought that was sort of such an important component that we maybe should give it its own slide in its own right. So I'm not talking about your Datadogs. I'm not talking about CloudWatch on AWS or Google's Stackdriver. I think it used to be called like logging systems here. When I'm talking about power of tracing and logging, I'm talking about tracing all of the inputs into our agentic system, all of the user queries into our LLM, and then all of the paths that the agent is taking through the graph to, first of all, send those prompts forward to LLMs, get responses back, and ultimately be able to see all of the telemetry that results in a response back to our user. So often CTOs maybe come to me and they sort of say, Darren, when should we start thinking about logging our approach? When should we start thinking about putting some of that telemetry in place? And maybe unhelpfully, I sort of say, well, when are you going to start using GitHub to store the code? So I think what I mean by that is this is an essential part of not monitoring the production system, but this is an essential part to actually build your generative AI app out and get it to production. So I've been saying for 10 or 15 years, it's not my line, but I'm going to pretend it is. Machine learning, AI, it's an empirical science. We need to experiment. And if you can't experiment and you can't see the telemetry of your agentic system and the responses that are coming in and how you responded, and then look at those responses and think, okay, well, I want my smart router to route to this particular intent in the future. How can I amend the system to achieve that? Then you're not really able to iterate and move forward. So I'd say this is one of the first things that you should be thinking about when you start out a new project. So an interesting sort of observation that we had on a project that we were working on this year was around using our intelligent router and the types of queries that we were sending to it. So you may be familiar, like all of the model providers will provide synchronous and asynchronous API endpoints for their models. Just to catch everyone up if you're not familiar. So synchronous is I call you up on the phone, you ask me a question, you wait on the phone for me until I give you an answer back. An async query would be more like you called me up on the phone, I'll send you an email back and I'll let you know when I've got the answer that way. So that's like you kind of explain it like I'm five sync versus async. So often your intelligent router will need to guardrail queries that come into the system. So what that's doing is making sure that your agentic system isn't responding to intents, to queries from users that you don't want to respond to. So my financial analysis app shouldn't be answering queries about what's the weather going to be today. It should politely respond, not really something that I'm particularly able to help you with, sir. Do you have any financial analysis questions? And so that that's the concept of guard railing. So it's a good thing to do. There's many reasons that you might want to apply it to your system, but obviously one of the challenges is it's going to add latency. So users come into your system, they ask a query. First of all, you need to check if that query is a good query or not, for want of a better expression. And then we if it is, we can proceed forward and sort of run the rest of the graph. Maybe perform a series of different LLM queries, bring some data back, and ultimately provide an answer to the user. The problem. So, how do you address that kind of latency challenge? Because you're adding something onto the front of the task. What we did was we took two parallel requests: one to the guardrails that would run asynchronously, one to the rest of the graph that would also run asynchronously. We can kick off the guardrails check. We can also kick off the rest of the graph. If the guardrails check's good, generally they are, because most queries that users send into the system are going to be of interest and something that you can help them with. So we're sort of optimistically parallel. And then if we get a positive guardrails check and we get a response back from our agentic system, we're able to forward that through to the user. If the guardrail responds probably more quickly than the rest of the other part of the graph does, we can cancel down. We can save the money on the tokens maybe that we've kicked off, because async tasks usually support cancellation. And we're not sitting around too long and running a big query only to say back to the user, we can't help you with that. So that's a good example of some of the ways that you consider the paradigms that you're sort of working in to address the the needs of your users and make sure you're responding in a timely fashion. Okay, the process. So this is our second pillar. So I know what you're thinking. You're looking at this slide and you're going to say, Darren, this pretty much describes any project I've ever worked on, right? You start off with a bit of ideation, you build out a pilot, and then if it's successful, you scale it up. There's not a lot of sort of interesting insight here. So what I would say about TensorOps and sort of the takeaway from this side that I'd like you to have is we spend a lot of time on this assess phase, on this phase one. Often at TensorOps, the assessment that we do maybe lasts for about 4 weeks. We'll work with your engineering team, your DevOps, your data scientists, of course, and data engineering. We're also bringing in the senior leadership team. We're often bringing in the C-suite. We're thinking about, your senior leadership. So we really want to understand your business. We want to understand some of the needs of your users and how we can combine AI into that product. And so I think, again, working in this industry for a fair while, I've seen a really common, and it was common 10 years ago, and it's really common today, sort of failure mode, which is a ML AI solution looking for a problem to solve. And I think those kinds of projects, when I encounter them, have often sort of reached a sort of are approaching failure because they probably haven't done this assess phase properly. And so if you do the assess phase properly, you've got a North Star for your team, you know where you're going, you know what problem you are addressing in your product with AI. You're not taking an AI solution and thinking about how you can solve any problem. So that's what I'd say is super interesting. Obviously, phase 2 and phase 3 also super important. But I think if you set the right direction, it's maybe a bit like orienteering. You set the right direction, you're not going to go too far off track. People and culture. So obviously, I have to say this is the most important part, because the people are everything. So you people here continuously upskilling. So don't need to worry too much about this. If you're giving up your free time on a Tuesday night, then you're focused on that. What I will say about this, obviously the assess phase goes pretty hand in hand with understanding the who of your project. So I think if we spend the right time on the assessment phase, we can work out who are the people in the organization that we need to bring in to address the challenge. I think another thing that I commonly see is in product companies especially, introducing AI into the product is very much a cross-cutting concern. And so what you'll often encounter is people in the DevOps team, people in the engineering team, people in the data engineering team, maybe some data scientists, some MLOps engineers, and lots of others. And oftentimes you can encounter those people working across different silos. And so it can be really challenging for a pilot to efficiently get that going if you're working across those silos. So to really empower the team and give them that autonomy, we often find taking a few of the different people across those different silos that I talked about, building a feature team, a product team that's going to work across those different silos, maybe sort of break down some of those handoffs, make sure that you've got something a bit more seamless, so that you're not sort of having like a low feedback environment. Helps you to really move more quickly, and it's also very empowering to sort of work that way. So that's something that we've definitely observed at TensorOps. Okay, 7 key lessons for scaling LLMs. Acknowledge your starting point. Recognize demo purgatory symptoms and use the maturity model to advance from simple prompts to tool using agents. Build an integrated stack, leverage a comprehensive platform that unifies MLOps and LLMOps workflows for scalable operations. De-risk with a golden path pilot. Start with a single high-impact use case to prove value and create a reusable architectural blueprint. Implement an intelligent query router, a foundational component for managing cost, performance, and user intent on complex LLM systems. Decouple your model serving layer, avoid vendor lock-in, and build for a multi-model future, ensuring flexibility and adaptability. Invest heavily in observability, use purpose-built tools. So the ones that I've used in the past, there are many others. I'm sure Selden's got one, and if they don't, they're working on one. Langsmith or Langfuse to trace and debug complex agent behavior effectively. Treat your prompts as code, apply engineering rigor to prompts, version control them, use templating, and implement A/B testing. I hope that's been helpful. Thanks very much for coming tonight, and happy to take any questions. If you don't want to ask a question now, come grab me at the end. We can talk one-on-one. Thanks very much. Do you want me to turn you on? Turn me on. What number mic is it? 3. Okay, I think you might maybe you need to turn it on at the bottom. Is the green light on at the bottom? Is there another one? Maybe it turns itself off as it hasn't had any input for a while. That one's also orange. Testing. Okay. So yeah, the AV gods have not been very kind to us this evening. Thanks a lot to Darren for bearing with us as well through the presentation. Very interesting. So hands up for questions. I will come over with the mic. Okay.
Hiya, Kyle. For your router, how are you doing your router? Is it based on, do you get the LLM? So do you get the LLM to answer what path it should take? Yeah, path it should take. And then on top of that, right, for the tool use, because for the tool use, do you invoke it? Do you bind the LLM with the tool, or do you split it based on the outcome of the classifier and then have the tool automatically invoked, if that makes sense?
Yeah, so I think you sort of described the intelligent query router pretty accurately. So questions are coming into the system, and the system's able to infer what sort of downstream agents would be the appropriate agent to maybe route that intent to. It's maybe less brittle than I've potentially made it sound, because if you're starting out building a system and you're and you're describing all of the discrete routes that any query can take through the system, then you're not building in a lot of flexibility. But I think I think the idea is that if you describe the different agents in your system and you've got some of that context, then the router can learn via the prompt which query might be an appropriate query to send the response to. And I think with the tools sort of side of things, I mean, that's like generally quite a separate concern. So tools usually sort of sit separately from from the routing sort of side of things, and those will usually maybe interact with agents downstream from the router. So it's just generally like good computer science sort of principles, like decoupling complexity, having the right sort of design and responsibilities in the system. Yeah.
Hi, my name is Salar. Yeah, very interesting talk, and I particularly wanted to ask about those tips and tricks in the last slides, where they learn through trial and error, and painful past experiences and failures, or do you recommend some resources that people can like read and dig deeper? Thanks.
Awesome. Yeah, thanks for the question. As I sort of said, AI ML, it's an empirical science. So they're certainly not just my learnings. I think we've got a lot of awesome colleagues at TensorOps that we've sort of worked on a lot of these different systems and share that knowledge across or our organization. I think it's definitely more the prior. I mean, I think we're all aware of the resources that you can sort of take on to learn some of the the ways to ways to use some of these sort of systems. But it's really, I find, only when you've got the problem in front of you and you're looking to solve and you're iterating and you're working with a a really motivated and interested product team trying to help them build their product, that you have that kind of constraint of, right, we need to get something to work. What can we do? What are the things that we can try, and iterating from there, and then having some of those technical tools around you that you can use to understand, the system that you've orchestrated, and then be able to feed back into how you can iterate forward from there. So yeah, it's messy. Thanks for asking for some of the challenges, some of the the roadblocks that we hit, because yeah, that's the reality of how this looks usually.
Hello, Darren. I've noticed you're bringing in some concepts there that seem recognizable for me as a DevOps guy. What do you think the kind of movement from being in DevOps into MLOps, is that going to be a painful transition, or can you cast some light?
No, not at all. Like I've got loads of colleagues, definitely, that I think gentleman at the front here was telling me that everyone wants to put AI in front of their title now. So if you become a AI DevOps practitioner, then you can start wearing that badge, and I'm sure you'll be fine. I think a lot of the principles between, I'm thinking of Venn diagrams. You had a Venn diagram on your presentation, Alex. So I think there's an awful lot of overlap between those two disciplines. I think the key difference for me between MLOps and and DevOps is that data dimension. So I think if you can kind of grok that one concept and sort of think about that, and how data is this extra paradigm aside from the code that you have and the configuration that you have in your system, that can be a sort of an agent of change in how your models and the code that you're running is operating, then that's the one thing to get your head around. And I think with with LLMs, again, I think it just moves a bit further. You're much more beholden to that upstream model. You don't have as much control over that, and the only really way to manifest that interface between your code, what your users are saying, it's sending into you, and those upstream models is those prompts. And so staying on top of those, having a lot of control of them, and thinking deeply about how you want to use them to, say, transition between models is the is the next sort of step forward from there. Yeah, so I don't think it's that hard. No, I think you'll be fine.
One small sub question, just very quick, if you may. Are there any tools I should be looking at to kind of unpack that data aspect?
I mean, I think you're in the room with the right people. If you're asking about how to learn more about MLOps, I'm sure the Selden team can really introduce you to some wonderful resources to kind of learn a bit about how they're doing things. I know they're also a pretty passionate open source company too, so I think there's a lot of a lot of stuff and resources that they'll have to share some of that. Maybe not to put him on the spot, maybe Alex can sync up with you later.
Yeah. Yeah, so I'd say in particular, look into the world of streaming data as well. We found that that's something that's incredibly useful in real-time applications. So from Selden's perspective, we're really heavily utilizing Kafka. So that's a really good place to start. A quick one over here.
Thank you. Hi, hello. Błażej Garski from Simplito Poland, a company which makes ML and LLMOps software for developers. I've got a question about reusability of all your solutions, because you are talking about routers, about a couple of ideas that should be actually implemented in every project. How much it is successful for you to reuse your solutions in next clients?
Yeah, so I mean, I think we're a consultancy, so we're generally working directly with customers and building bespoke solutions to their problems. I think, yeah, I'm not kind of advocating too much of a sort of framework, approach here. I think we definitely are familiar with a lot of the different tools that we have preferences around the tools that we'll use with our customers, but we're also able to align to where they are. One of the challenges, one of the joys of being a consultant is you have to align to the customers, where they are, and understanding their tech stack. They might be on a variety of different clouds, that kind of thing. I think still having those concepts clear is valuable. But in terms of reuse, we're not necessarily copying solutions between customers when we're rolling stuff out. But I think having those conceptual ideas about how we're going to solve problems is definitely useful.
Okay, thanks.
I think there's some questions at the front as well, Alex.
Okay, last two questions
on the way down.
Yeah, and then we'll wrap.
Thank you.
Yeah, so I mean, I think as I mentioned, so one of the tools that we use quite extensively for evaluation of prompts and building sort of test suites for the LLMs that we're working with, I've used like LangSwift quite a lot for that. So it has not only the support for logging the sort of intents that are coming into the system, the queries and the things that you're doing in your in your sort of agent graph, but also the ability to specify a set of test prompts that you can use to then build an evaluation set on the model to make sure it's kind of aligning to the task that you've got for it. So that's one of the frameworks I've used. Absolutely, yeah.
Perfect segue. I was about to ask about evaluation, and if you have standard way of approaching that, or do you have different way of approaching evaluation offline and online, depending on the client facing you, and also how deep you go in the evaluation side, because it can take time. It can depend on evaluating only the LLM or the system or the tool calling, all of that. So
thanks so much. Yeah, that's an awesome question. So I think it's very it's very germane with the idea of taking your demo and bringing it to production. So when you get to production, evaluation in a sense becomes easier because you're able to collect more data and evaluate where the model's going wrong and respond to that. I think that's why I think following some of these principles and getting something out in front of real users quickly can be really valuable. I think it's also something that really requires subject matter expertise. So for example, going into an organization generally is, we're seeking to understand the business, but in general, the people working inside that organization will understand what makes sense for their users in the context of their product. And so they can help us build out some of those evaluation sets as well. And often maybe say in a search context, you've got a good idea of what good responses look like, and you can maybe leverage that to get the results that you might want.
Thank you.
I think I see one online question popping up. So recognizing that some people have also dialed in, we do have the time.
Thank you for dialing in. Awesome.
We have a question which I will read out. Thank you for posting online, Pedro. How do you manage expectations with clients when they want to reach from level 0 to 2 ASAP, but they must go through 1 first?
Yeah, I mean, I think that's you know, that's not a question just about AI or MLOps. It's a question about life, really, isn't it? It's sort of how do we go from A to B? So I think often having an idea about the vector that you're heading down, the direction that you're heading in, is more important, and it's more important to think about the sort of the short steps that you need to take to get there. So I think often you can't go from 0 to 2 in one step, but I think we can sort of break it down and think what the small steps are that we need to get there. So it's not sorry, I don't have like a compelling like shortcut for you all, but yeah, I think unfortunately that's not what life's like. It's it's a grind. Yeah.
Okay, thank you. And actually, related question, I suppose. We've seen an increasing kind of democratization of AI tooling. Previously you had to be a data scientist to get anywhere in ML, and these days, obviously, everyone's a prompt engineer. Now we're seeing things like OpenAI's releasing Agent Kit. You see Copilot Studio rolled out across hundreds of thousands of companies, making it more accessible for people without, kind of technical skills, you could say, to develop agents. What do you see as the potential challenge of and how that will, evolve given the complexity and challenges of, these applications falling over as well?
So the short answer is obviously I don't know. I think my kind of take on that kind of angle is I think it's great to bring more people into the fold. I think that the last question to the gentleman in the pink top, I forget your name, sorry. I think is really related to this. So I think having more people with subject matter expertise building agents that can really bring not a technical perspective or a consultant perspective, understanding the how of achieving things, but more the what of what the user wants can be really, really valuable. And it's a bit like in here, it's a big room. There's lots of space for everybody to get involved, and I think that can be really useful. I think it challenges some of the governance and some of the ways that we work as teams. But I think if you if you sort of embrace that and sort of iterate fast, then I think that can be a really successful outcome for for approaching things. And in my career, I think context about the domain that you're operating in can be more important than technical acumen. And even better, I think combining someone with domain expertise with someone with that technical acumen can be a great recipe for success as well.
Perfect. Okay, thanks a lot, Darren. Really appreciate your talk. Yeah. So we're running actually pretty much bang on time. Actually, we were like 3 minutes early, which is excellent. So we are going to have a short break now. And if I can ask everyone to be sort of back in the seats in about 5 minutes, that would be great. So that we can kick off with the next talk, which will be our very own Paul from Selden. Yeah, looking forward to diving deeper into agentic AI after the break. Thank you.